Hello everyone, welcome back to another live session, and we will be looking at curriculum based task this time around. So welcome. Please go ahead and ensure you have your books, your papers, your pencils, pens, or whatever you're going to need. And I will encourage you to use I will encourage you to use your brains to do your calculation, and so we're not relying on calculators. So, as usual, I want to welcome you, big welcome, and I hope you have done pretty well in the ability task. I hope you did fairly well. And now that we're going to do a little practice on the curriculum based task, I want you to first go ahead and just share the school that you're joining in from. Go ahead, share the school that you're joining in from. So I know where in Jamaica or even where in the world you are tuning in from. All right, so we're just going to look at some sample items, and as time goes by, we will also look at some past paper items or similar curriculum-based items that will help us to prepare for our next component of the PEP. All right, so this first item here is, it says the diagram below shows the back of a truck, which is the shape of a rectangular prism. So far you realize that we're looking at solids. Boxes shaped like volume, shaped like cubes will be loaded into the back of the truck. So we're now looking at volume. The dimensions of the back of the truck, which is not drawn to scale, are shown below. So take a good look at this truck here. Take a good look at the truck, take a good look at the dimensions, because the question that will come next, or the statement or the further instructions, will be to use two of the numbers from the list below right here to complete this sentence so that the statement is true. Remember, go ahead, type in the chat, let us know which school you're tuning in from. Also, go ahead and share the link with your friends, with your classmates, so that they don't miss out on these sessions as well. All right. All right. Welcome, Petersville Primary. Welcome, Frankfield. Welcome, Cambridge. Welcome, Liberty Academy. Go ahead and think about this. So based on this item here, we are definitely looking at solids because it says rectangular prism. So we're looking at solids. It says boxes shaped like cubes will be loaded into the back of this truck. And if we're thinking about cubes and loading in and looking at the dimensions, we're talking about the volume of the back of the truck as well. So we're going to use two of these numbers from the list to complete the sentence below to make the statement true. So the different numbers are the different things we have here. We have 1 meter, 2 meters, 3 meters, 9, 24, 216. And the statement says if the edge of each box is blank, then the back of the truck can hold blank boxes. Welcome Woodall, welcome St. Michael's. So go ahead and look. Look at the dimensions that we have here. What do we need to know? What do we first need to know to start thinking about how to complete this sentence? What do we first need to know? If the edge of each box is blank, what could the edge of each? And remember now, the boxes are what we're going to load into the back of this truck. The boxes are shaped like cubes. If the boxes are shaped like cubes, what does that mean? What dimensions are we thinking about, or what dimensions could we be thinking about? Also, we might need to know the capacity of this truck back, right? So we can know how many of that certain kind of box can hold there. Go ahead and share with us, how do you think we can go about answering this question? All right. So we have to first think about the space, the size, the capacity of this truck back. So what's the capacity of the back of this truck? How much space I think we have in this truck back here based on the given dimensions? Go ahead, do your calculations. What's the space or what's the volume or capacity you think this truck back has? Because it says if the edge of each box is dashed, we don't know. We have to first know the space, the amount of space or the volume or the capacity of this drop back before we can go ahead and think about the edge of the box and how much, how much boxes the back of the truck can hold, stuff like that. Now, Lane Lloyd, I see you put 216. What does 216 mean? All right, there we go now. Very good. So you have 216 cubic meters. What are you talking about there, Lalaine? What are you talking about when you say 216 cubic meters? What is that measurement associated with? What measurement are you giving me? So you said 216 cubic meters. What is that about? So it's good to put your answers in sentences so we're on the right track and we're able to you know understand what you're saying, and we're not mixing it up with another question. Okay, you're talking about the volume, so you're talking about the truck back having that kind of volume. All right, good. So to get that kind of volume, I would see where you multiplied three different dimensions. So to get volume, we normally multiply or find the product of three dimensions. So based on what we're seeing here, the dimension of the back of the truck would be this. We have one dimension here, one dimension here, and whether we want to call it the height or something, we have another one here, and we can choose to call it whichever we might want to call it. The breadth, we can call them width, whatever you want to call them, but we've got three dimensions. Of course, my lines aren't straight, but I hope you get the gist. And the arrows are there showing us the dimensions. So we are finding the volume of the back of the truck. So now that we have found the volume by multiplying the length by the width times the height, 6 times 4 times 9 meters, and that gave us 216 cubic meters. So I'm just going to put it here because that's how we find volume, by multiplying three dimensions. And this gave us 216 cubic meters. And I hope everyone else is following, or I hope you all had similar or the same, basically the same calculation. So we would have found the volume of the back of the truck. So now that we have found the volume of the back of the truck, it says here if the edge of each box, and the boxes are shaped like cubes, those are loaded in the back of this truck. So if the edge of each box is what measurement, then the back of the truck can hold how many boxes? Go ahead and do your calculation. So you gave us the volume, Lalaine. However, we still have to complete this statement. So we still have to complete that statement. All right. So I know you're all doing your work out there. Welcome for the persons who have just joined. We just started. And the thing to know about curriculum-based task, each item is basically, everything in that item is related. Once we move to our next item, it's basically a new question, So here we have just started the first item, so you have not really missed out on anything. So far, we have calculated the volume of the back of the truck because we're trying to complete this statement. So since you're just joining, you can go ahead and start reading what is happening here. All right. Yes, very good, Shamala Dockery. But remember, we cannot leave our units. We cannot leave our units. So yes, we have calculated our volume. But how do we complete this statement at the bottom? If the edge of each box is blank. If the edge of each box is what? If we're talking about, if we say the boxes are shaped like cubes, what do we know about those dimensions? What will those dimensions have in common? Go ahead and tell me. What does a cube, what do the dimensions of a cube have in common? So that is something we must think about first, because we're now going to be talking about the box, which are the boxes which are shaped like cubes. What do you know about a cube? So yes, we know a cube is a solid, but what do we know about the dimensions of a cube? What do we know about the dimensions of a cube? And if you're thinking about a cube, you can think about a die, like a dice. You can think about that because that is a perfect example of a cube. And we also have the Rubik's Cube, the one with the many colors that we turn it to, match them up and ensure that we have same colors on each side or whatever pattern we're trying to create with it. Those are examples of cubes. What do you know about the dimensions of a cube? Yes, darn it, they're all equal. The dimensions are all equal. So yes, the cube is like a dice, as I mentioned, and all the dimension, that means the edges are all equal. All right. Yes, Lalane is made up of 2D squares. So the faces are square faces. Cubes are made up of square faces. Very good. So we know all of that. So we know then that whatever at one dimension of the cube that we're going to select here is, it means that all the dimensions will be the same. So it says if the edge of each box is what? 1 meter, 2 meters, 3 meters. Let's think about these dimensions here. If the edge of each box is 1 meter, 2 meters, or 3 meters, then the back of the truck can hold how many boxes? Let's think about that part. Then the back of the truck can hold how many boxes? So for me, what I did, I was looking at the numbers here. I'm looking at the numbers here and I'm trying to see what numbers, what relationship I can see or, determine from these given numbers. I looked at the 3 meters and the 9 and I'm like, ooh, 3 times 3 gives me 9. But then we're talking about the cubes and how many of them. And if we're talking about cubes, we're talking about the volume, 3 different dimensions here, the volume. So I understand that totally we have to be thinking about 3 different dimensions. So those are some of the things that I thought about when, trying to decide this number. So if the edge of the box is what? So let me look at 3. So I'm trying to find the volume of one of these cubes. If we look at 3, say for example, one dimension of the cube, the little boxes which are shaped like cubes, one dimension is 3 meters. That means the volume of one cube would be what? Go ahead and share that in the chat. The volume of one cube would be what? So if I say that, okay, the edge of each box is 3 meters, what will be the volume of that box? All right. Okay, darn it. Okay, you're giving me some numbers here, but we're trying to complete this statement. So we need to know what will go on this first blank line and what will be on the next one. So we're completing this statement. So I'm just looking at one of these numbers because I was trying to find some sort of relationship between the numbers here. So I first thought about, oh, 3 meters. If the edge if of each box is 3 meters, and I'm just going to go ahead and draw, let me get another color and draw a cube, not drawn to scale. Oh. All right. Now these faces should actually be squares. So it's not drawn to scale. I'm just trying to get a cube here. And I'm putting broken lines here because basically I cannot see through the box, thinking that it's opaque. All right, so here is the cube, and this is like the box, and I'm looking at if the edge of each of the box is 3 meters. Let me just get a color here to identify those edges. So that means this is one of them. This is one of them. And this is one of them. So I'm thinking about those 3 dimensions. If one of the dimension is 3 meters, what would the volume be of this particular box? Come on, guys. So we know that volume is calculated by multiplying 3 dimensions. Dimensions, we basically call them the length, the width, and the height. So length times width times height. We generally call them, name those dimensions as that. So if we're multiplying to find the volume of one cube, one of the box, what would the volume of this box be? What would the volume of this box be? Because now we need to see if the volume of this box, we need to see what relationship the volume of this box will have with the volume of the back of the truck, which is this. This is the volume of the back of the truck, which we had calculated earlier. So go ahead and share. What do you think the volume of one box will be? If the edge of each is 3 meters. All right. All right. So if it is that the cube, remember we just talked about the cube, that all the edges have the same length, right? So if one edge is 3 meters, that means all the edges is also 3 meters. All right. So Shanieka Sharp says 27 cubic meters. So let's see if that will really be so. 3 multiplied by 3, that will give us 9. And 9 times 3, that will be 27. Very good. I see Lalaine working that out for us. All right. So that would mean that the volume of one box is 27 cubic meters. Now, if we have 27 cubic meters for one box, I'm just going to write that down right here so we're all following. So we're like 3 times 3 times 3 gave us 27 cubic meters. If one box is 27 cubic meters, how many will hold in the back of the truck with this volume? Go ahead and calculate that. All right, go ahead and calculate that. And tell me then if those numbers will work to complete this statement or to make this statement true. Go ahead and tell me, would these numbers 3 meters and 216 cubic meters, would that make this statement true? Come on, guys. I need to see you doing some calculations and sharing your answers here. All right. I need to see some calculation because remember now, we have to work on our speed and accuracy because our exam, the exam that will take place in a few weeks, in a couple of weeks, is time bound, just like all your exams. So we have to think about how much we are working, how quick we are working, and if we are working speedily to answer all the questions that we may get on the paper. So let us look at it. All right, so Lalaine says 216 divided by 27 equal 8. Why did you divide 216 by 27, Lalaine? Why? Why did you divide them? So we have the back of the truck having a volume of 216 cubic meters and one box that we will be loading in the back of the truck. We're going to load boxes in the back of the truck and one of the box will have a volume of 27 cubic meters. Why did you divide 216 by 27? Go ahead, just share a sentence or so that will help us to understand your answer, your calculation. All right, Nia. So you got the same as Lalaine, but how did you get it? And why are we dividing 216 by 27? Tell me, Tanya, why are we dividing 216 by 27? And the fact that we got 8, what does that mean? Does it mean that is the correct answer, or does it mean that we need to try other numbers? Why did you do that division? So you went ahead, you divided the volume of the truck by the volume of one of the box, and you got 8. That means you're saying that 8, the truck, the back of the truck can hold 8 boxes. Is that what you're saying? And if it is that you're saying the back of the truck can hold 8 boxes, does it mean that because we don't have any 8 here and one of these numbers should go on this line? If it is that we don't have that, explain to us then what do we now need to do? All right, so Lalaine says she divided 216 by 27 because she wants to know how many boxes can hold in the truck. All right, very good. Very good. Let me see. Tanya says she divided 216 by 27 because the 216 is the volume of the truck and the 27 is the volume of one box. So the answer is 8. All right. All right. I agree with you guys. That's what I would have done too. I just wanted to know your reason. All right, because we may have different reasons. So, yes, so you actually did that. Okay, Nia said because if the truck is 216 cubic meters and the box is 27 cubic meters, then it shows the amount of boxes the truck can hold. Brilliant. Very good. Now, so we know that. That means then we will have 3 meters here and we would have 8 here. But while we have 3 meters, do we have 8? Do we have 8? Do we have 8 in any of the numbers? Because I'm not seeing 8 here. So that simply means then that 3 meters cannot work. We cannot work with 3 meters because 3 meters, if the edge of each box is 3 meters, then the back of the truck can hold 8 boxes, but we don't have 8 here. So this brings us to try another number. What other number can you try? You go ahead, select your number, try it out. When you get your answer and it seems as if that is definitely working, go ahead and share your answer in the chat so we can see what you are doing. So we know that 3 meters cannot work because this box with 3 meters, 3 times 3 times 3 gave us 27 cubic meters. And when we divide this 27 cubic meters into this 216 cubic meters, which is the volume of the back of the truck, then we realize we get 8 boxes, but we don't have 8 here. So it cannot work. But what can work? Darn it, Harvey says 1 meter. Can you tell us a little more about that, darn it? You said 1 meter. So you said 1 meter. How, you said 1 meter. How did you know that? What did you do to figure out that, yes, we can try 1 meter? How? Go ahead and explain to us. And in the meantime, I'm going to draw a line through this here because this one did not work. But you said 1 meter. So if you say 1 meter, it means then that the volume of one box will be what? If you say that if the edge of each box is 1 meter, then tell me, what is the volume of that box? What's the volume of one box? Tell me. For the persons who shared 1 meter and for the persons who... All right, so you divide 216 by 12. Where did you get 12 from, Tanya? Where did you get 12 from? How did you get 12? Because, okay, all right, but how did you get 12? So you got 18 when you divided that, but how did you get 12? And also bear in mind that we don't have 12 here in any of the numbers, nor do we have 18. But where did you come from? Where did you get 12? What did you do to come up with 12? Let's think about it. Someone said 1 meter. So if it is then that we can use 1 meter, that would mean 1, which is the length, multiplied by 1, multiplied by 1, and that will be equal to what? What would that be equal to? 1 times 1 times 1. Okay, so you said you used 4, but how did you come up with 4, Tanya? So I want to know, because whatever, if you say here, all right, so Nia says 2 can't work. All right, there are persons saying 1 meter, but how did you come up with 1 meter? So here it says the edge of each box is blank. Someone said 1 meter, so we're going to try 1 meter. So if the edge of each box is 1 meter, we're going to now find the volume for that box. So to find the volume, remember we have to multiply the 3 dimensions because in a cube, all the edges are the same length. So here we have 1 times 1, 1 times 1, 1. So this would be 1 cubic meters or cubic meter. That's what this would mean. That's what this would mean, because 1 times 1 times 1 is equal to 1. It is not 1 plus 1 plus 1 equal to 3. So pay note of that. Volume, we're multiplying, we're not adding. So if it is that, then one box, the volume of one box is 1 cubic meter. And we need to see how many of this 1 cubic meter box can hold in this back of this truck, which has 216 cubic meter for its volume. Then how can we use that information to complete this sentence? Go ahead and show how we can, if it matches in this sentence here. So if the edge of one box is 1 meter, then the back of the truck can hold how many boxes? So I need to see that complete statement in the chat. I need to see that complete statement in the chat if it is correct. If you think that can work, I need to see it in the chat. Now, if it does not work, we have to try 2 meters. So let us see for 1 meter, will it work? Will we get numbers here to complete, to put on these 2 blank spaces? Now, Tahira, you're saying 216 divided by 9 is equal to 24. But look at it now. If the edge of each box is this, whatever number here has to come with a unit. So whatever number comes here, it has to either be 3 meters, and we check that out and we see that one not going to work. It has to either be 2 meters or it has to be 1 meter. So we have to think about using these numbers here. And when we use these numbers, will we get any of these? When we plug in these and use the appropriate operation, will we get any of these 3 numbers? So you're saying 216 divided by 24 equals 9, but now, Tahira, we have to think about those numbers in context. We can't just be using these numbers here and putting in some operation, and because it comes out with one of the other number means it's correct. Remember, there's a statement that we're completing. If the edge of one box the edge of one box must be a number with a unit. So Nia says if the edge of each box is 1 meter, then the back of the truck can hold 216 boxes. Let us see. So we will have to say 216 cubic meters divided by 1 cubic meter. So 216 divided by 1 is equal to, I see somebody up here already calculated that. HP Yang said 216 divided by 1 is equal to 216. So because we know that 216 divided by 1 is equal to 216, that seems as if that can work, because right here it says if the edge of one box is 1 meter, so this 1 meter here working out, let me go ahead and put that in the spot. 1 meter. All right. I'm just going to plug in those numbers that you have shared based on your calculation. I'm going to plug in the numbers because I see one person so far gave me the complete sentence. So let us look at it. 216 right here. So now remember that whatever we get for this one must have a unit. 1 meter. And 216 is a number of boxes. So 216 doesn't have to have any meter on it. But whatever number we get here for the edge of each box must have a unit. So in order to check if this is correct, we look at the volume of the back of the truck back, and I'm doing some tongue twister here. I'm talking about boxes and back and all those things. So if it is that we divide this 216 cubic meter by 1 meter, the 1 cubic meter box, we should get 216 boxes. And that's why this one will work perfectly. Because this one here, where we get 1 cubic meter for the volume of one box, it worked well with 1 meter times 1 meter times 1 meter, because 1 times 1 is 1 and 1 times 1 is 1. So we come up with this 1 cubic meter. And so the correct answer, or the correct numbers, definitely have to be 1 meter and 216. As you can see, we would have completed these here. And we spent a good deal of time on this one, but I'm definitely loving the discussion. But let us move on to our next one. Very good, guys. Let us move on to our next question. And don't worry, you can always come back to this to this video, because it will be posted for you and you will be able to come back to it. All right. So here, item number 2 says, given the following square-based pyramid. I need to make this smaller so we can see the question and the pyramid at the same time. Given the following square-based pyramid, respond to each statement below with either true or false. If the statement is false, write the correct statement in the space provided. So we're going to look at this square-based pyramid, and we're going to put true or false if the statement them true or false. So let's go. So we know that a square-based pyramid, a pyramid is where all of those faces, they meet at the top here, the faces attached to the base, they meet at the top here at an apex or a vertex, we can call it that as well. So all of them, they meet up here. A pyramid always have a little pointy part at the top. So, and it's called square base because the base is a square and all the triangles coming up to meet at the top. All right, so the first statement here says the solid has 4 vertices. Do you know what a vertices is or vertexes? Do you know what vertices are? Because you have to know that so you can answer this question. Do you know what a vertex is or what are vertices? Go ahead and share. What are vertices? Go ahead and share that in the chat. Go ahead, share that in the chat. What are vertices? All right, so Nia, I see you put false. Okay, cool. But what are vertices? Let's just talk about that real quick. Just put a sentence in the chat, guys, to tell me what vertices are. What are vertices? All right. All right. So Nia says the points where the lines meet, or let's say where the edges meet. So we talk about vertices when we're talking about solids. We talk about angles when we're talking about, 2D, we're talking about shapes. So let's look at vertices here because we're talking about solids. So we're talking about where 2 or more edges meet. So the vertices or the vertex is where 2 or more edges they meet at a point, like right here. So the pointed part of a figure, Taira says the pointed part of a figure, we can work with that. Ashley says vertices where the points meet. Yes, we can work with all of those things. All right. And Brittany says where 2 edges meet. We can work with those. So for example, right here is a vertex. So it says a solid has 4 vertices. Is that true or false? The solid has 4 vertices. True or false? Let's look at this solid, square-based pyramid. It has 4 vertices. True, false. We're just answering true, false. If it's false, we need to write the correct statement. But if it's true, then we're good. All right, yes, we can say the vertices are the points. Yes, but we have to talk about where the edges meet as well, right? All right, so Tanya and Devani says true. Okay, let me hear what the others think. True or false? The solid has 4 vertices. Rankin says false. Why do you say false, Rankin? Because if you say false, we have to write what is the correct thing then. Tahira says false and Brittany says false. So what is the correct thing? Remember it says, if it's true, we write true, but if it's false, we need to write false and give the true statement. So Chrissy says it has 5 vertices. All right, let's check that out. Let us check that out. So let us look at the vertices. All right, for right now we know that this here is 1. And at the edge here, the corner here again, we have some faces meeting, some edges meeting. That's another 1. Behind here that we can't see, but it is there, is another 1. That's 3 so far. Here is another vertex. And here is another vertex. Let's see how many we have. If we have 4. 1, 2, 3, 4, 5. So it's definitely false. So first we need to write false. And we have to pay attention to the instruction, guys. We have to pay attention to the instruction. So when we answer, we get our full marks. So the correct statement is, all right. Okay, I see you guys saying it has 5 vertices. Now we have to write it in a sentence based on the sentence given. The sentence given says the solid has 4 vertices. So we're going to write the solid has 5 vertices because we just counted them. And that is the correct statement. All right, very good. Now we have to take note, guys. We have to make sure we're looking closely at the figure. So not because we're looking and say, oh, we're seeing 4 at the bottom here. Don't forget the 1 at the top. All right, so B says the solid has 8 edges. The solid has 8 edges. Go ahead. Is B true or false? Is B true or false? Go ahead and look at that. It has 8 edges. What is the edge? What is considered to be the edge in a solid? All right, and it says true because it has 8 edges. All right, so what is an edge? What is an edge? We need to talk about that because in order to know if it has 8 edges, we must know what an edge is. So what is an edge? The side parts, for real? The side parts looks like the faces. I don't know. Let's think about a proper definition for an edge. What is an edge? Yes, Pinky. Yes. Very good. Vertices are often denoted by letters. Okay. All right. The side parts or the lines. That's what Tanya says. Tell me, what do you know about edges? I'm waiting to see at least one description of an edge. What is an edge? Very good, Tahira. Edge is where 2 faces meet. This triangular face meeting with this triangular face at this edge. This triangular face meeting with the one at the back at this edge. So when we talk about the edge, it is basically almost like the corners. Or yeah, we can actually maybe want to look at it and say that in a solid. So the edges is where we have 2 faces meeting. So let's go ahead and count to see if we have 8 edges. So we have 1 here, 2, this one at this back here, 3, we have 4, down here at the bottom, put this triangular face and this side of the square. We've got 5, this 1, 2, 6. Around here, we have 1, 7, and this one 8. I hope we have counted them all and I hope you're following me as we're counting. So the statement says a solid has 8 edges, and based on what I'm seeing, that looks like it's true. So the persons who have said true, well done. It is true. We have counted 8 edges. An edge is where 2 faces meet. Don't forget that. Don't forget that. If you take up your tooth, the box that your toothpaste come in, the corner part there, so not the vertices, not where the different faces are meeting up, the different edges are meeting up at a point. You realize at the side, there's a part when you move from one face and going down to the next, you pass that edge. So two faces, when they meet, it forms an edge. Let us look at C. Yes, Marika, very good. Vertices is at the top, or we can call it the apex. Brilliant. All right, so C says the solid has no equilateral triangles as faces. Wow. Now, we need to know what are equilateral triangles. Do you know what equilateral triangles are? What are equilateral triangles? Go ahead and tell me, what are equilateral triangles? What do you know about equilateral triangles? Because I think equilateral triangles is given a name. It seems as if it's a special kind of triangle. Anissa says all the sides are equal. Very well. And I agree. In equilateral triangles, all the sides of that triangle equal. Good. So now let's look at it. Here it says the solid has no equilateral triangles as faces. Let us look at this triangle. All right, Nia says triangle that have all equal sides. Devani says all three sides are equal. Good. Let's look at the square-based pyramid now. Do we see any equilateral triangles here as faces? All right, very good Chrissy K and very good Tahira. So, are we seeing any equilateral triangle on this solid? Do we see any equilateral triangle? Well, we can see a triangle here at the front, and let me just try to outline this triangle so we can at least recognize it a little. My lines are a little squiggly, but they're meant to be straight. So that is one of the triangle. And if the base is a square and they all meet at the top at an apex, tell me, what does it mean? Does it mean that all the triangles are the same size? All right. All right, so this is one of the triangle from this solid. And based on the measurements given, it is showing that from here to here is 7 centimeters. And from here to here is 5 centimeters. So far, we would look and we realize that if this is 7 and this is 5, I mean, those two sides are already of different lengths. So definitely that cannot be an equilateral triangle. But if we continue around here and we say, all right, this is another equilateral, this is another triangle. And if you are following what is happening with this solid, you realize that all these edges from the base to the apex or to the top vertex here, you realize that they are all of the same length. And because the base is 5 centimeters, it means that the bottom of the triangle, one side of the triangle, will have to be 5 centimeters. And so it means that the solid has no equilateral triangles. All the triangles would be of the same size. So C would mean that, yes, I see lots of persons saying false. C would mean that it is false. There are no, the solid has no equilateral triangles as faces. C would mean that the answer is true. There are no equilateral triangles as faces. So the correct answer for C is true. Let me see what you guys have written. Do you agree with that? Now, I see where the statement says there are no equilateral triangle as faces. So because it says no, some of us may be confused a little and thinking that, oh, our answer is false. But remember that the word no is here in the statement. So it's true that there are no equilateral triangles in this solid as faces. What about D? All right, guys, very good. I see your answers coming in. What about D? D says the solid has no isosceles triangles as faces. Wow, isosceles triangles. What is an isosceles triangle? What do you know about isosceles triangles? Go ahead and tell me what is special about isosceles triangles. Why do they have that name? What is an isosceles triangle? Yes, two sides are equal. Yes, Anissa. In an isosceles triangle, two sides are equal. Two of the sides must be equal in an isosceles triangle. So that means the third side is not the same length as those two sides. Very good. All right. So let me just go ahead and erase what we have here so we can observe this solid clearly. So let us see if this is indeed true. The solid has no isosceles triangle as faces. All right, so I'm just going to go ahead and draw one of these triangles here. And that length I've drawn so far is 7 centimeters. As you can see, this one here is also 7 centimeters. And this one here is 5 centimeters. So it means then that this triangle, if you say 2 of the length is the same, must be the same, that means this triangle is an isosceles triangle. Let me try to make another triangle with another face. But yeah, we have established already that all these faces are um, of the same dimensions, right? But I'm just going to do another one here still. So this length, we know it's 7 centimeters. This one here is also 7 centimeters. And this length here that is a part of the square base is 5 centimeters. So therefore, this is also an isosceles triangle. So where it says the solid has no isosceles triangles as faces, that is false because the triangles are all isosceles triangles. So we're going to put our answer in as false. And what will be the true statement? I want to write one of your true statements. So go ahead and tell me what would the true statement be? Because remember, we have to correct the ones that are false. What would the true statement be? So the solid has no isosceles triangle as faces. False. So how would we correct this statement? I see that you guys are saying false, but how would we correct the statement? How could we correct this statement? All right. Go ahead and type the correct statement in the chat. So if it says that, if it's false that the solid has no isosceles triangles as faces, what is the true statement going to be? What's the correct statement? So it could read, okay, Nia says the triangle has all isosceles triangles as faces. Torian says all of the triangles are isosceles triangle. Now we're correcting the statement, Torian. So we're going to write a similar statement to that. Devani says the solid has 3 isosceles triangles as faces. Are you sure it's 3, Devani? The solid has how many isosceles triangles? Is it 3? Look at them. We have 2 on this side. Remember now the square base has 4 parts, So it has to be 4 triangles attached to that square base to meet at this apex. So I have only outlined 2 here that we can see, but around here with the broken line shows that there are more. So let me go ahead and outline the others. All right, so right here, I'm going to go ahead and outline the others. And because of how the solid is, it may look as if the sides are not straight, but are not the same length. But remember that the base, they're coming from the base to the apex. So we have to think about it that. So this is another triangle. And if we look at it from that side, it will be an isosceles triangle. So there we have 3 isosceles triangle so far. And here on the other side, where is it? Right here. Would be another isosceles triangle. So yes, you guys are correct. 4 isosceles triangle. So let's go back to our statement here. So the solid has 4 isosceles triangles as faces. And that is the correct statement. So I hope that is what you all have. The solid has 4 isosceles triangles as faces. That's the correct statement. Remember that the base is a square. So it has to be 4 triangles coming from each of the side of the square going to the top. So it has to be 4 triangles. All right, good. Now the last one here says, opposite sides of the base in the solid are not equal in length. Opposite sides of the base in the solid are not equal in length. Now, you all should know that because we have exhausted that point, right? About the base. So the base has what shape? What shape does the base have? If you know the shape of the base, then you can answer this question. What shape does the base have? Abigail says it's a square. Okay, well, everyone is saying it's a square. Very good. So if it is that the base is a square, opposite sides of the base in the solid are not equal in length. Is that true or false? Nia says false. So if it is false, because a square has 4 equal sides, that means the opposite sides must be equal. All the sides are equal. So yes, we're going to go ahead and put our false. But what? We need to write the correct statement. So what could the correct statement be? Waiting for your answers in the chat. What could the correct statement be? Go ahead. Let me see your... Yes, Gianna, it's a square base. Very good. Let me see your correct statement for this one. So if it is false that opposite sides of the base in the solid are not equal in length, then what is the correct statement? Remember that whatever statement we're going to write, it must come from based on what we have here. So we will start by saying opposite sides. All right, so Abigail says opposite sides of the base in the solid are all equal, and we don't have to put all equal, we can just say equal. So we're going to have equal only, are equal in length. All right, and I see Anissa, Torian, Gianna, Tat D, Devani, Tanya. I see a lot of persons, Anissa, Naya Official, we're all agreeing that this is the correct statement. So make sure you have the correct statement there in your notes. And then we're going to move on to our next question. Now you have been doing very good so far. So this question is one of a stem and leaf plot. You know, stem and leaf plot is one way that we can represent data. So in grade 6, you would have just met stem and leaf plot in grade 6 being taught in your regular day-to-day class. So a stem and leaf plot is, as I said before, is a way of representing data, just like how we can use bar graph and, you know, pie chart and line graph and histogram, pictograph, and so on. All right, so here the stem and leaf plot below shows the number of marbles each student in a class collected. Do you know how to read the stem and leaf plot? Give me a yes or a no in the chat, or a thumbs up or a thumbs down. Do you know how to read the stem and leaf plot? Go ahead and share. Do you know how to read it? Of course, I will go through it a little, whether or not. But tell me, do you know how to read the stem and leaf plot? All right, very good. That's what I like to see. Very good. All right. All right. All right. So, all right. All right. So many of you, all of you responding so far, know how to read the stem and leaf plot. So, all right, but I see some persons saying no. So, of course, I will be going through them. So, the stem and leaf plot, it's almost like we're looking at numbers with a tens place and with a ones place. So, the numbers on this side, based on this stem and leaf plot, would represent the tens place of whatever number we're coming up with. And you look at the numbers on this part, these single digits will represent the ones in the number. So for the first one, we have 0 tens and 2 ones. That would mean 2 marbles. This one says 0 tens and 8 ones. That would mean 8 marbles. We have 0 tens and 9 ones. That would mean 9 marbles. Now for the next part, we have 1 10 and 0 ones. That would mean 10 marbles. 1 10, 0 ones. We have here 1 10, 2 ones. That would mean 12 marbles. 1 tens, 4 ones. That's 14 marbles. 3 tens, 6 ones. That's 36 marbles. And I'm just picking out the random places now and creating numbers from what we have here. So when we're reading the stem and leaf plot, basically the numbers on this side, as per this example, represent the tens place, and each of these represent the ones place. All right, so do we understand that so far? And the key also helps you to understand this. It says that 3 on this side and 1 on this side represents 31. So the key will also help you to understand this graph. All right, now let us go to the first question. All right, let's go to the first question. The first question says, all right, the first question says we're going to use, but we first need to pick up this, this says the stem and leaf plot below shows the number of marbles each student in a class collected. So when I scroll up on this page, you may not see that instruction anymore. So it shows the number of marbles each student in a class collected. Now we're going to use the information in this stem and leaf plot to answer these questions. How many students were in the class? How many students were in the class? Now, Remember that these show the number of marbles each student collected. So here, one student collected 0 and 2, 2 marbles. One collected 8 marbles. One collected 9 marbles. That's how many students so far? 3 students. We have one collected 10 marbles. One collected 12. One collected another the other collected 12. One collected 14. One collected 19. Let's see how many students we have here. 1, 2, 3, 4, 5. So 5 and 3, 8 students are there so far. We have here 23. One collected 28. One collected 28 again, and another collected 28. So this is 1, 2, 3, 4 students here. Then we have one collecting 31, one collecting 34, one collecting 36. 3 more students here. So the total number of students is 3 plus 5 plus 4 plus 3 equals 15 students. So some of you are way ahead of me. Good. I like that. Because remember, we have to be, capitalizing on our speed as well as being accurate. So how many students were in the class? 15 students. All right, so we put our answer here. All right. Now the next question says, what is the mode number of marbles? What is the mode number of marbles? Now we need to know what mode is. What is mode? What is mode? The mode number of marbles? What's that? When they say mode, what do they mean? What does it mean when we're talking about the mode number or the modal number? What is that? What do we call the modal number or the mode number? When we talk about mode, what are we referring to? All right, so Tat D says which number appear the most? And Abby is saying that the numbers are repeated, all right? Now, the numbers can be repeated because look at this, 12, 12 are repeated. We have 2 12. But we're talking about the most frequent one, the one that occurs the most. So I see other persons putting in their submitting responses, the one that appears the most frequent. Those are some responses we're looking for. So which number appears the most? So let's look in the ones place here to see if that can help us to determine. Because the tens positions or the numbers that are on the stem here, they help us to, we can see how many of the ones, how many of the same number we can get. So we just need to focus mainly on the leaf here with the ones position. So we have two twos here in the ones position in this row. So we have 2 12. Let's go to the next one. We have 128, 228, 328. And with this row here, we have none of them reoccurring. So we have 12 2 times, but we have 28 3 times. So the modal number of marbles is 28. Because we have 3 students collecting 28 marbles. So yes, very good, guys. I see you are putting in your answers. And I appreciate the ones, especially who are writing their answers in sentences. Now, for this here, you don't need to write a sentence because when you get your paper, it will already have the line on it. And basically, the length of the line shows you that you just need to write the number here. So, but that's very good. I like to see your answers in context. Very good. Let's move on to C. It says here, what is the average number of marbles that each student had? And we're going to show working. So on your paper, when you're doing your exam, say show working, make sure you show working. And even if it doesn't say the show working, always remember to show working. All right, so in your performance task, in your curriculum-based task, it is very important to show working. All right, so what is the average number of marbles that each student had? Wow. Now, if we're thinking about the average number of marbles, what do we need to do to calculate this? Now, this will take some time because now in finding the average, what do we need to do? What do we need to do if we're finding the average? Oh, yes, I forgot. Thank you for reminding me. All right, so tell me though. Yes, we're gonna add all the numbers. So go ahead, start adding all the numbers. But when you add all the numbers, what do we do? Okay, Torian says add then divide. So we add all the numbers and then we divide it by what? We divide it by the number of students that we have. So let's go ahead and start doing our addition. I'm also doing my addition here. So you go ahead and you do your addition. When you're through with your addition, share your sum in the chat. Share your sum in the chat when you're through adding. All right. Okay. Go ahead and share your sum first in the chat. All right. So Williams and Chrissy K says 294. Very good. I got that too. So let us go ahead now and divide that by what? What are we dividing that by? What are we dividing that by? We're going to divide it to, okay, we're going to divide it by 15. Rankin says we divide 294 by 15. But I see you have 19.6, Rankin. Tell me, we're talking about the average number of marbles. If we have a 0.6, that looks like a fraction of one marble. So tell me, what is the average? Average number of marbles. We can't have a 0.6 marble. All right, so we added and we got 294 and we divided by 15 and we got 19.6. But what is the average? Yes, we round up to 20. The average marble is 20 marbles. Because we're looking at the rounding principle. We know that 5 and up, we round up by 1, or below 5, we round down, or the number remains as the whole. Depends on what we're rounding to, but we're rounding to whole number here because they don't have a fraction of a marble. They have whole marbles. So we're going to round it to 20 marbles. The average number of marbles will be 20 marbles. Now that you have done your workout there, I'm just going to put a workout here. So we add all of them and we got 294 as sum. And then we divide that by the 15 students. And we get an approximate answer, which is 20 marbles when rounded up. So of course, your workout will not just show this. In your workout, you need to be showing where you added 2 plus 9, 2 plus 8 plus 9 plus 10 plus 12 plus 12 plus 14 plus 19 plus 23 plus 28 plus 28 plus 28 plus 31 plus 34 plus 36 to get your 294. And then you divide by your 15 to get your 19 and remainder, which you're going to round up to 20. All right. Very good work so far. Let's see how much more we can complete today. So let us look here. Item 4 says there were 30 pencils in a box. Some pencils were removed and now there are 12 pencils remaining. Using P to represent the number of pencils that were removed, which two of the algebraic expressions below can be used to determine the number of pencils removed? Now, I want you guys to go ahead from this statement. There were 30 pencils in a box. 30 pencils in a box. Some pencils were removed, and now there are 12 pencils remaining. Using P to represent the number of pencils that were removed, go ahead and write your algebraic expression. And when you have written your algebraic expression, you're going to look at these that we have here, the 6 that are here, and see which two could represent that information. All right. Okay, so I see some responses coming in. Now it says which two 9 official. It says which two, so B cannot only be the answer. William says A and B. Nia says B and E. Rankin says B and D. All right, I see persons coming in with their responses. Anissa says B and A. Gianna says B and D. All right. All right, let's see. Let's see. So we're going to write our expression. So we have 30 pencils in a box. And these are basically equations anyway. We have 30 pencils in a box. Some pencils were removed. We don't know how many. So if we're removing, we're going to subtract 30, take away. And we use P for the pencils removed. And there are 12 pencils remaining. So after we take out P pencils from the 30, we have 12 pencils remaining. 30 take away P equal 12. It's right here at B. So far, B is a correct answer. Now, how else can we structure this to mean the same thing? We know that if we are subtracting, if we take this number from the one that we have here and we get this, we can always add this number and this number to get back this one. So we're going to look at that. So let's see what's happening here. So here we have P take away 30 equal 12. No, because that would mean that P pencils is more than 30 pencils that were in a box. So this one can't work. 30 plus P equals 12. That would mean then that we didn't take any pencil out. And I mean, 12 is already a big number. If we add something to 30, we cannot get a smaller number, 12. If we add a positive number to, if we add P to 30. If we have here at D, we have 30 divided by P. It did not say that 30 pencils were in a group or anything. So it said take away, right? Removed. So we cannot have anything showing a division. Here it says 12 plus P is equal to 30. Now here is showing that the 12 pencils remaining plus the pencils taken out will give us 30. And that makes sense because if it is that we had, I'm trying to remember if this one is a subtrahend or what, but whatever this one is, let me call it the minuend or so, I don't remember. So this one here, if we add this minuend to the difference, we should get this number at the front, which is, I think, the subtrahend, the bigger number. So with that, we know that p plus 12 will give us 30, or 12 plus p will give us 30. So that is also a correct answer. And if any of you remember which one is the minuend and which one is the subtrahend, go ahead and remind me there in the chat. All right, so let's look at F. 12 times P will give us 30. This one will not match up because it says some were removed. The pencils were removed. So this one will not work. A multiplication there will not work. And so the correct answers are B and E. So Dijonay, Watson says B and E, Rankin says B and D, Tahira, Devani Murdoch, I see person saying B and E. And for the persons who did not get B and E, please go ahead, look back at your numbers, look back at these equations, look to see if the first one that we got from the statement here, which of these will give us the same responses? Which of these would mean that P would have to be the same value? All right. And remember, you can always go back to this video to check to see which one is correct, or check to see what explanation we gave for these. All right, very well. Now let us go to item number 5. You're doing really good so far. Let's go to item number 5. So number 5 says the table below shows a pattern created with blocks. So you see, no matter what, we are always going to run back into pattern. Now we're going to complete the table by writing the number of blocks for each term. And here I want your help to help me with this one here. So we're going to complete the table by writing the number of blocks for each term. Now the first term, how many blocks do we have in the first term? Go ahead, share your answers in the chat. And I know some of you will calculate faster than I am. So you can put first term, you put the number of blocks, first term equal, second term equal, and so on. So go right ahead and tell me, how many blocks are there in the first term, in the second term, third term, fourth term, etc. Now, guys, if you just write a random number, that does not say anything for me. All right. So Kayla says term 1 equals 6. Anissa agrees. Darnett is saying 4. All right. She retracted that. I guess she made a mistake. No problem with that. All right. So Nightmare says 6 in term 1. Dijonay says first term equals 6. So let us look. I'm going to count these cubes. 1, 2, 3, 4, 5, 6. So yes, there are 6 blocks in the first term. Yeah, you're correct. Very good. Let's go to the second term. How many blocks in the second term? How many blocks do we have in the second term? And feel free to calculate for the third term and the fourth term. So you know you cannot just write a single number in the chat. You have to write second term equal or third term equal. All right. So William says first term is 6, second term is 12, third is 24, 4 is 48. How did you get that? How did you get that? Williams, how did you come up with that? All right. Abigail Golden says second term is 12. All right. So basically in the second term, it's 2 of what we have in the first term, right? So 2 of this outline, this pattern in the first term is second term. So that means that 2 times the 6 will give us 12. And the third term is what? Third term, I see people say third term is 24. Where did you get 24 from? How did you get 24, Anissa? Go ahead and share that explanation with us in the chat. Nia, we are multiplying the numbers by 2. Which numbers we are multiplying by 2? Roger says the third term have 24. Yeah? How did you get that? Dictionary Watson says it as well. I hope this is a little better. Sutherland, I hope that's a little better. All right, so basically, we multiplied the first term by 2 and we got the second term because we can see that we're doubling the previous term each time. Okay, you say 18. Why did you say 18, Roger? Tell me. So here you can see, basically what we're seeing here is that we have 4 of the first pattern here. We have 2 here, we have 1, 2, 4. So tell me, what do you think should be here for the third term? All right, so I'm seeing some explanations coming in. Dejane says they are multiplying by 2 each time. Nia says multiplying the first term by 2 to get the second term, etc. Anissa says because the second term equals 12. For the third term, it's 12 times 2, 24. All right, no, Roger says they're going up by 6 each time. They went up by 6 for the second term, but look at the third term. We see 6 and 6, this is in the second term, but look, we've got 2 more set of 6s. Here, look at that, Roger. Let's think about that. So it means then we have 2 of this pattern. So 2 times 12, because we have 4 here, we've got 2, and this is doubled to 4. So 2 times 12 will give us 24. So I'm seeing some explanation from some people, and they're really good, because they're doubling each time. Do you notice that they're doubling each time? So the first term was 6, but they doubled the pattern in the first term, which is, and gave us 2. Then they double the pattern in the second term, which is 2, and we now have 4. Now let us see if in the fourth term they doubled as well. So if they doubled in the fourth term, well, if it double the third term and we get the fourth term, we have 1, 2, 3, 4 patterns in the third term. And in the fourth term, let's see if we have double 4. Double 4 is 8. 1, 2, 3, 4, 5, 6, 7, 8. Good. So if we have 8 here, how many blocks do we have in the fourth term? All right. I see some person saying fourth term as 48 blocks. And you're so right. Because each time we're doubling what is in the previous term. Just like we doubled 6 to get 12, we doubled 12 to get 24. We're doubling 24 now and we got 48. Very good. But the question is asking, how many blocks will be there in the fifth term? Fifth term, and one person says fifth term equals. or term 5 equals. 9 official says term 5 is 48. Think about that a little. Devani says fifth term is 96. All right, HP Young is going a bit further there. Looks good. So in the fifth term, we're doubling what is in the previous term. That means 48 multiplied by 2. So 48 multiplied by 2 will give us I like to do my pen and paper workout, because I like to show work and capitalize on any little marks that is there for me to get. So here we have 48 multiplied by 2, 2 times 8, 16, 6 ones, 1 10, 2 times 4 tens, 8, 8 tens plus 1 10, 9. So we have 96. So in the fifth term, we have 96 blocks. Many of you have that. Very good. Very good. So we have 96 blocks in the fifth term. Now, down to figuring out the rule in words. Can you write a sentence or two to describe the rule or to tell us the rule? All right, go ahead, write a sentence or two to explain to us what the rule is. And I know that each of you most likely will word it differently, but once it is basically correct and talking about the same thing, then we're good. Go ahead and type the rule. And while you are typing the rule in the chat, I want to invite any teacher here. If it is that you have any curriculum, any past curriculum paper or so that you would like for me to go live and work out, feel free to send it in an email to primathzoom@gmail.com, and I'll be more than happy to explore that live one of these Saturday mornings. So feel free to send it to this email address. All right, so I see persons are writing explanations, but it's not enough for, it's not enough. Like, we multiplied each number by 2 to get 96. What number? Be specific. We need to be precise in what we're saying. The rule is multiply the number by 2. What number? Tat D says the numbers are doubled in every term. All right, that will work. But we need to talk about the previous numbers are doubled for the next term, or something like that. Simone says the rule is to multiply by 2 each time to get the next term. That is good. We can have that. Lenora Sanderson says each time they double the previous number. All right. Abigail Golden says the rule is multiply the first term by 2 to get the second term, and so on. So we multiply each term by 2 to get the next term. So we can have that. All right. Dejane says double each term by 2. Well, if we double each term, we multiply it by 2. So you can say double each term to get the next term, or we multiply each term by 2 to get the next term. All right. Multiply the previous term by 2 to get the present term. Okay, we can say that. All right, very good. So we don't have to multiply. We don't have to multiply at all, because we can also just add it twice or add it to each other. Add the 48 to 48 to get this, or the 24 to 24 to get this. We can definitely do that as well. Very good to point that out, HPN. All right, so very good. So in your exam, you would basically go ahead and write the rule for the pattern here in the term. All right, very good, guys. Let's go to the next one. I'm just moving my email address down so that persons who have not seen it yet, teachers specifically, you can always send send up a past paper, or send any paper which is curriculum based that you would like for me to explore here. I'll try my best to go through all of them. So this one says grade 6 students were collecting data for a class project. They wanted to find out which ice cream flavor was most popular. A total of 100 students were surveyed. The data collected from each student is shown in the table below. So here in this table, we see the flavors: vanilla, chocolate, strawberry, grape nut, rum, and raisin, and the number of students that likes vanilla the most, chocolate the most, strawberry, grape nut, rum, and raisin. Now the question is saying which graph would be most appropriate to represent this data. Go ahead. Which graph could we use to represent this data? Which graph could we use to represent this data here? Share the name of the graph in the chat. And once you have decided on your graph, you can also go ahead and start to sketch your graph. All right. All right. So persons are saying bar graph, pie chart, picture graph, photograph. Okay. All right, bar graph. All right, so we have bar graph, we have pictograph, we have pie chart. Good. Those are very good options. So remember now we have a total of 100 students. If it is that we use, say, a bar graph, if we use a bar graph, we have to think about the key that we're using, the scale that we're using to see how much we're going to go up by, to see how, if it is that we're doing a bar graph, if we're going to have any very wide space, or we're jumping from a number to a lot larger number. Would a bar graph be most appropriate? It says most appropriate. Now, while we could use a bar graph, very good graph to use, and we also mention a picture graph, pictograph. Some people say picture graph, some say pictograph. So we can use a pictograph as well. But it says most appropriate. So we can use a pictograph, and we can use different pictures to represent these different flavors of ice cream. A pie chart. A pie chart is also good because a pie chart is like a circle, and it's really representing a whole, like it could be a 100% or so on. And here it says a total of 100 students were surveyed. I mean, that looks perfect for a pie chart. I mean, if you ask me. So we could use a pictograph, we could use a bar graph, we could use a pie chart, but which is most appropriate? Which is most appropriate? 100 students were surveyed. Which is most appropriate? What do you think? We can use all the graphs that you have listed because, truth be told, most of these data can be represented on many different graphs. But which one is most appropriate? Go ahead. Which one is most appropriate? Just type that in the chat. Which one is most appropriate? All right. All right. So some persons can use a bar. Some can use the pictograph, but the most appropriate graph would be the pie chart, because the pie chart is really out of 100, like percentage. And here we have 100 students. So we can see the different sections, the different size, the different number, or if there are more students choosing this and very small amount choosing that, we can definitely use a pie chart, and that would show whatever we're doing, clearly. And I am not saying, as I said before, the bar graph could not work, nor the pictograph, but it says most appropriate, and that would be the pie chart. Now, it says to represent the data using the graph you named in part A. A well-labeled sketch is acceptable. Now, I chose to use a pie chart because I believe it is most appropriate. So I'm going to, do a sketch using a pie chart. If you decide that bar graph is most appropriate, but I think we can agree that a pie chart is most appropriate here. While a bar graph can be used and a pictograph and many other graphs, a pie chart would be most appropriate. So it says to represent the data. Let me get this a little smaller. On a pie chart. Now, I'm just going to go ahead and make a circle. This will not be drawn to scale because I'm just about going to try to draw something here. So I'm just going to go ahead and do a rough circle, a rough pie chart. Not bad. All right. So here it says we have 45, we have 30. So we have 45 choosing vanilla. 45 is close to 50, but it's not 50, and 50 would have been halfway. So let me go ahead and I'm going to say okay. So halfway would be down here, but it's not fully halfway, so I'm just going to bring it across a little like this. And this will be vanilla. All right, so let me put vanilla here. And you can go ahead and sketch your graph as well. I'm going to put vanilla here. Let me just put van for my vanilla. I might not have enough space to write it. But if it is that you're going to do, say, van for vanilla, remember you need to have a key. So the markers know what van mean. Or no, if you shade this in red, all of this part in red, you need to have a key to show that the red part is vanilla, because that is something very important. It must be a well-labeled sketch. It has to be labeled properly. So, or maybe I'll just do the red for my vanilla. So now let me go up a little more now. Well, I can see 5 being grape nut. I'm going to use grape nut. So let me just tick off vanilla, and I'm going to do grape nut because at least I can mark this, and this can be halfway down. 45 plus 5. I'm just going to bring it down here and call this part grape nut. So let me put a G here for grape nut. And all the time I'm choosing something to represent each part of this pie chart, I am adding that to my key. So you're going to have your key, whether you're going to have it right here, key. And if you're going to color code it, or you're going to use something, I can put, my G here, and then I write the word, or I might have a little green square, and then I might just write the word grape nut, and I'm going to may use a little red thing to show vanilla. So you have to make sure your key is there. If your key is not there, then that means nobody can understand your pie chart, so I can do that, and I can type vanilla, the whole word vanilla and so on. Let's now look at another flavor ice cream. All right, so we have chocolate 30, and half of this 50 would be 25. So a little more than half can be 30. So let me go ahead and I'm going to draw that in. This would have been half, so a little more than half can be 30, and that can be my chocolate. I hope you're drawing yours as well. I'm going to put CH chocolate, and each time I write something, I'm adding it to my key. So blue is chocolate, and I'm going to write up the whole word chocolate. All right, so we have 3 flavors represented. We have strawberry 10 and rum and raisin 10. So strawberry 10, we have 2 more, so we're just going to divide this remaining part equally. Now let me just fix this properly. Everything has to come from the center properly. Let me just fix this properly here. And remember, it's not drawn to scale. I'm just using my free hand. But you, on the other hand, should ensure that you're using something round to draw your pie chart and using your ruler to make sure it's neat and tidy and that someone can look at it and understand what you have. So I hope you are doing your pie chart. So we have strawberry and rum and raisins. So I'm going to just use a different color. Let me find this and I put, this is strawberry. And every time I just add it to my thing and I write the word strawberry beside this yellow color and then rum and raisin. Let me use this one for rum and raisin. All right. And I add that as well to my key. So that will be a well-labeled diagram. So I'm going to put this color here and I'm writing out the word beside it, rum and raisin. You realize I didn't write them out, but you should write them out in yours. Rum and raisin, strawberry, chocolate, vanilla, grape nut, because the key must match this diagram. All right. So we have our well-labeled sketch here, and I hope you guys have also done yours, your well-labeled sketch that will allow you to get full marks once you have that. And look at this now. This pie chart here has no title. We're going to go ahead and we are going to find what the title could be from up here. What do you think the title could be for this pie chart? Give me some examples in the chat. What title do you think this pie chart could have? This is the last question, guys. What title do you think this pie chart could have? Go ahead and share a possible title in the chat. Go ahead, share a possible title in the chat. So let me just go back up to what we started out with. Grade 6 students were collecting data for a class project. They wanted to find out which ice cream flavor was most popular. So go ahead and tell me what could be a possible title for this pie chart. Possible title. Anissa says favorite flavors of students in grade 6. Favorite what flavors? We have to be, precise. Ice cream flavors of grades, favorite ice cream flavors of grade 6 students. That could work. So let us use that. Favorite ice cream flavors of grade 6 students. All right, this can work. So we have our title, we have our key, and we have done our sketch in a properly way. So yes, we can work with that. Popular ice cream flavors, very good, Tanisha. Students' favorite ice cream in grade 6. Those are really good. Titles. Very good. And if it is that we were doing a bar graph or any other graph, we need to have our title. We have our key as well. And if it is a bar graph we were doing, we have to make sure our scales or different axes are labeled appropriately. Now, the question that will be asked next is this. If the graph in part B alone was given, that means if this was the only graph given, what are two conclusions that could be made from it? So go ahead in the chat. That's the final question. This graph, let me make it a little bigger. If this graph was the only thing given, what are two conclusions that could be made from it? So go ahead, write your conclusions in a sentence. What are two conclusions that could be made from it? All right. And see why it's important to have our title, because if we didn't have our title, we would not understand what this thing here mean. Because it really could have meant that these are the I don't know, the flavors that they don't like most. I don't know. But it could mean something else. And so the title is important. So go ahead, give me two conclusions that could be made from this graph. Give me. Anissa says more students prefer vanilla than any other flavors. Very good. That conclusion can be drawn because this big part is for vanilla. Very good. What else could we, what other conclusion could we draw from this? So I've heard from Anissa. What conclusion can we draw from this graph? All right, Darnett says it tells the favorite ice cream flavors of grade 6 students. Right, it does because the title says that. But what conclusion can we draw based on the data here? We're looking at the data. What can we say about the data? Yes, Tanisha, vanilla is the favorite ice cream. All right. So we're talking about what conclusion can be drawn. So we know that vanilla is liked by most students. What else could we say about this? Grape nut is the least favorite of all. Very good, Tat D. Nia says the most popular flavor of ice cream is vanilla. The same number of students like strawberry and rum and raisin. Very good, Nia. All right. Anissa says less students prefer grape nut than any other flavors. Very good. Grape nut is the least favorite of all ice cream. Darnett says. Abby Gay Golden says they are the favorite ice cream flavors of grade 6 students, and each space represents an ice cream flavor. Yes, but based on the data, though, Abigail, based on the data, what are the conclusions? Tanisha says grape nut is the least favorite. All right. All right. All right. So those are some conclusions we can draw. Someone says vanilla is the most favorite, or the most liked ice cream, I should say. Vanilla is the favorite. Abby says vanilla is the most selected ice cream. Very good, Abigail. Yes, that's the kind of conclusion we're talking about. Very good. Grape nut is the least favorite. Yes, we can see that. Strawberry and rum and raisin have the same amount of people choosing them. Yes, we can say that. Chocolate is the second favorite. Those are some are some things that some conclusions that we can draw from this. We can also say that the number of students choosing chocolate, rum and raisin, and strawberry is the same as the number of students choosing vanilla and grape nut. We can also say that. So definitely, guys, there are many conclusions we can draw from this. All right. Now, I appreciate all your answers, and I appreciate all of you for joining me today. I hope that you all have subscribed and you have hit the notification bell, because as you could see with this one, I didn't send out a prior ad for it. So sometimes I will just come on and just go live. All right. And if it is that you have any curriculum based task you would want to send to the email for me to explore, go ahead and do that, so I can always prepare for that and send out an ad to share with people and to invite people to join us on YouTube. All right, so don't forget to practice. Your exam is coming up really, really soon. I am proud of you guys, in fact, and I know that you guys are doing well and will continue to do well. All right, so yes, Nia, I know you have subscribed. You're always on my live. Nice, well done. All right, so remember, this is my email address for you to send any curriculum-based paper to, and I will go ahead and explore it for you. Have a good Saturday, and some days next week I may just come on, so stay tuned. Have a good Saturday. Bye bye.